Da-da-da-da. Oh, here's Jim already. Hey, it's Coffee Compiler Club. We got a small crowd today. It's all good. We're all being recorded. You'll be up on YouTube within an hour, here to talk about compilers and anything else. And that's it for the spiel. Let me throw Jim in. There we go. And I don't know, somebody have an opening thing? I could tell what I'm just doing with AA, but it's high theory things that I'm still sorting my brain around. I don't know if people would care.
Yeah, go.
Do the thing. I'm sweating. Let's see what's the right way to bring this up here. I am sweating out unification between code that generically, oh, I need a Google Docs. This is a Google Docs thing. So I don't have a prepared presentation, so I don't know what to do with an example here. So here I'll write a little example here. So factorial is a function which takes an x, and if it's less than or equal to 1, returns to 1, otherwise returns x times the fact of x minus 1. And what is the type?
We can also share.
Oh yeah, I'm sorry. I typed it and I didn't share it. Let me dun, 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 dun. Okay, so what is the type of factorial here? This is a really standard factorial line. I could break it up, make it a little more clear here, but it's not, there's absolutely no well, there's no good indentation. I haven't figured out yet. I don't have an indentation plan.
So if we go the Hindley-Miller way, it should be int. If we go the structural way, there should be something that has a multiply and a minus method.
Yeah, right. Yeah, exactly. So what is the type of factorial? Well, it seems obvious that the factorial of 3 will be equal to 6, but this should work with factorial of 2.1, which would be equal to something crazy like 2.1 times 1.1 times 1, right? Okay, but what does it mean to be equal to factorial 2.1? Well, it turns out that if I were to do factorial of some matrix thingy that had some elements, I don't know what it really means is that factorial is a function which takes a thing here of A, which has operators for plus, minus, multiply, less than or equal to. And it returns me an instance of the same thing. Let me make sure it's a function returning another A, I believe. I'll have to go look and make sure it's not returning an int. So if I replace this with an X here, your answer for integers are the same. Your answers for float are a little different. Okay, so what it amounts to is factorial is a function of anything that takes some operators. So that's my goal. Okay. In the unification process, I discover that I've got this type here for operators being whatever, and I end up unifying against like int. So I'm doing a unify step at some point in the middle of my algorithm, which is unifying an A with operators versus an int. Versus some ints, call it 3, right? This is the type int. So how does that unification work? Well, somewhere under the hood, I really declare 3 is something like an int class here, and that's not a good way to write it, and a base with 3. So I've expanded secretly the Hindley-Miller type of a base 3 to be the int class and a 3, and then I can unify the operators here. And actually, when I throw the operators in, they always have one more layer of indirection. So there's some kind of a struct-like thing which has some extra fields I don't know, and some class fields, which include an operators. And now I can unify these things. And then what's the end result? Well, the operators here allow more other operators in case, because fact doesn't care if you have more operators. So it unifies cleanly with the int class, which has all those operators plus a bunch more. And then the second ... the one I'm trying to highlight there, says, I don't care what other fields you have. Maybe you're a matrix fields, maybe you're float fields, maybe you're an int fields, and they unify with the int fields. So just sorting out why, when I was running factorial a couple of different ways here, I got in this funny zone where, depending on the random die roll of the work list, I would either have an integer class as the result, or a base of 3 or 4, whatever my base was. I would have an actual base that hadn't been expanded, and I had an error in the unification where it wasn't doing the thing right. And that's because I hadn't semantically worked out that this is the unification I'm actually trying to accomplish here. Here's another way to format the layout on this, make the unification look a little more clear.
But I'm beginning to think, wouldn't that increase the complexity greatly, because you have to search for all the types that have all these methods?
Well, the unification versus int only happens when I unify factorial as a function call with an int class, which is this one up here. So it just means that when I do unification, like you pull up fact as an identifier, standard Hindley-Milner, you make a fresh copy of it, then you unify and as a function, and you unify it with an argument. You make a function call, unify the argument 3 against the type of A in the factorial, the first type. So that's the unification of A versus
because
3.
You have you can go the structural way. You can almost always would get no type errors here, but you can, when you apply at the call side, you have to figure out how to make this work.
Yeah, exactly. Right. So I had to do something with 3. And I didn't get it correct the first pass, and that was where I was sorting out why it failed one way or another.
So you would say at the cow side here, you would say I'm passing the 3. Does the 3 has the required methods, the multiply and the comparison and the minus? So it's all good. If it can figure it out. So
yes, but the deal I was having there was that the 3 was being represented as a base type from Hindley-Milner, so base 3. But it actually is a class of an integer class with a constant 3 as the value. And the integer class supports those operators. So I had to explicitly expand the base 3 into an int class plus the base part.
Most of the type inference first try with the literal, but once it cannot get it right, it will expand it one step in order to.
Well, that was the deal. I needed to expand the base. It had to semantically be as if I expanded the base 3 all the time. And I didn't do that right. I have a lazy expansion point. I didn't get it right. The same thing happens here if I were to using a 2.1. The floats guy have to be, pre-expanded. And then that'll also unify correctly. And then some matrixy thing or whatever, somebody has some other weird type going on. As long as it supports those operators, and you take an int on the right-hand side, like the less than has an int, the subtract has an int, the multiply has a version of itself. So multiply is, so the operators have more specificity than what I was saying. But they,
So if the type here results to its structural in order to qualify into its structural qualifiers in order to be a valid type for the factorial, it will start, let's say, with 3. It will see the 3 is an int literal that tells him nothing. It will try to expand in order to search for the operators needed to fulfill.
And what I needed to do was just not have a step in the algorithm where you expand it, but instead semantically it's as if it's always expanded. And then if the expansion happens to be lazy, and it turns out I'm not being lazy here at all. I actually expand them now eagerly, and I just didn't get it right everywhere. The other thing I was trying to point out was the operator minus here is typed to take an A and an int and produce, what's this thing produce here? The minus produces another A. The multiply is typed as a function that takes an A and produces an A. And the less than is typed as a function that takes an A and an int and produces a bool, which means just an int one.
Mhm.
And that's kind of the actual
So-
type that it shows up as for factorial, and therefore you can have a matrix as long as it supports matrix
Mhm.
of
In order-
subtract with an int and matrix of multiply and a matrix of a compare versus an
Yeah.
int.
I get it. You want to expand you want to expand the type lazily in order to retain its most specific type. If
No, I
don't
want
try
to
to-
expand it lazily strictly for performance. It
okay.
has to be semantically as if it's always expanded.
Mm.
So for people who showed up late here, we're like sorting out my latest go around with AA typing. And basically I'm coming around to kind of, so this is on ints and floats, but matrix, I'm kind of discovering subclassing or classing relationships indirectly, sort of automatically here. It's just kind of a wild ass thing that happens that falls out of this setup. So
Because-
factorial is defined up here is a standard factorial. I ask, what is the type? Nothing in the type says you have to be an integer to int. You'll take an int, return an int. But if you take an int, you'll return an int, and that's unify with the factorial of 3 is a 6. But you can do factorial on floats, and the math all works. I mean, it's a funny answer. But then as soon as you can do math on floats or ints, you can do math on some matrix thing. That should also be fine. And then you get this type for float for factorial, which says I'm passed an A type, which has some operators, subtract, multiply, less than, and I produce an A type back out. And as long as I take any A, as long as it has these operators, and then end up doing unification of operators of minus, multiply, less than, whatever, versus the ints or versus the floats or versus a matrix or whatever it's going to be. And I hadn't been doing that correctly. And now that I've talked it through online here, I think I know where I'm going, why I did wrong and what I'm going to do to fix it. And easy fix.
Oh, of course. Well, that's why we're here.
Yeah, exactly.
So by calling fac with something I've never called it with before, is there a chance that I'm going to end up creating a new function? A sort of new instance of the generic?
There's, what am I doing here? Okay, semantically, fact is always generic.
Mhm.
My intent here is to take things that have primitive operators in the middle and specialize by the primitive type, but there'll be a generic one for a matrix. So, I would like to believe at some future date, I'll have 3 copies of fact running around the system. One that takes ints, one that takes floats, one that takes generic things with the right operators and does a generic
That's-
lookup.
Also the most performant way.
Yeah. Like even these
performant for
operators
the-
on a generic lookup, I'll turn into a virtual call overhead only. It'll be given a matrix class, given any class, I'll just do a V call to get the multiply, add, and subtract operators out of it.
Mhm.
And then that might specialize to get rid of the V calls, but you can imagine a matrix times a matrix is so big and heavy that I don't care. The V calls nothing compared to the matrix multiply.
Yeah.
The
Yeah,
entire
so we
time
have
you're
an as if
explaining-
rule that says I could make a very generic thing that gets called in lots of places and
Yeah.
put ifs in it to do runtime type checking. I could make 3 versions of it that are specialized to the 3 different types.
Yeah.
As
Almost
if rule
surely-
says the compiler gets to pick between the 2.
Right. Almost surely you'll get a generic one as a fallback situation, and then there'll be
Because-
specialization will be up to the runtime to decide that he's going
Yeah.
to take the V call and the call to fact to split out ints from floats from matrix.
That
Yes,
also
yeah.
has to be the case if you have a library and you haven't used the factorial.
Right. Yeah. So I'll make a generic one. And then as you call it, if you're calling it with primitives, then I'll decide, I being the runtime compiler will decide, pick out which ones
How
to
does it-
specialize on.
So you as a developer may or may not care about that overhead of the
Yeah.
virtual call.
Yes.
And
If
what
you
are-
care, then you can cast it to an int. If you just put fact up here as I expect X to be an int, the problem goes away. right? If you just say it's an int copy, it's an int, and then there's no question, right?
Yeah, so it's obvious to me how the writer of the fact function can say, I care, and I want to make it specialized to an int. I was thinking the other way. If you are a user of the library,
right,
and you want to know that this library is not introducing virtual calls.
Can't type, right? I just take the copy I'm given and I make a cast to an int to int version.
So now I've told the language explicitly.
Yeah, this will
make me a specialized version. Now I'm going to call my specialized
well,
version.
my fact will be typed as an int. If you pass it something else, it will fail. Because it's only typed as an int, I'm hoping that the runtime will. I mean, I would like to make a belief that the runtime will hard force just the int version. You've already proven it's going to be an int in and an int out. That he would just go to the specialized version right away. There's nothing in here that's going to tell me the user. I didn't write an int in the typing per se. Like the type for fact himself is unchanged, but the specialized version will have an int to int everywhere. And so I'm hoping the code gen has a straightforward way to say, all right, we'll just do ints here. That is I have to look at that, but that's how I would say you demand an int version.
It will create the most specialized version, so it can, if it can figure out from the code side that there is no need to be classes, it can replace it with ints, but make a copy of the factorial.
If the entire program consists of a fact of 3 and the program ends, then fact never escapes. It's not in your public space library. It has exactly 3. The typing can be forced to an int throughout, and it's done. It's now just it just cleans up as an int. And
I mean, if it's literally that, then the only thing that's going to show up in your binary is the integer itself. Fact is going to disappear.
We had a couple guys talking at once. I overlapped, couldn't hear.
I said if it's literally that, then constant propagation. The only thing that's going to show up in the binary is return and the value.
Yes. Well, once you get past
fact
typing,
will disappear entirely into constant propagation.
Right. Typing says it's an int to int. Constant propagation says, in fact, it's a 6, and we're done. Yeah. All right. Somebody else was saying something in there.
Yeah. Levo and then Alan.
Levo.
The entire time your
sound dropped, Levo.
Yeah.
Yes. I was just wondering what. I'll try to
repeat. Now.
You're back. You could stay. All right. I don't have any. While I have screen sharing on, I can't see all participants, so I don't know if Levo comes and goes.
I'm still here, so you guys can definitely hear me.
Yeah.
Yes, and you dropped a while ago, but you're not dropped now, so carry on. Okay, now I've got the participants I can see. Yes, fire away.
So the entire time you're explaining, I was just wondering what happens if you have a bug. So let's say you're doing an integer, a float, and some kind of matrix factorial. And you forgot to write the if statement, and then you just write a bunch of code with a matrix, passing in a matrix, and then you realize, oh, I made a mistake here. I need an if statement, but you can't really do it correctly with a.
Your sound dropped again.
Crap.
So I think the idea is,
and then half your code is going to give you an error.
Okay, you dropped it in the middle again. You get like 30 seconds on, 10 seconds off.
I think the idea is that you do it, it types correctly, but then you realize you need to change the algo, and now it doesn't type correctly, and all your code is broken.
But that would be the case for any program you wrote in C or Fortran or Java as well. You have a broken program, you have a broken program.
Yeah.
Well,
I don't know if that's
how would you check the program to it won't match the types if you accidentally.
So if you know what you think the types ought to be, and it's currently typed, and you realize you have a bug and you want to change something, and when you change it, it no longer types, you probably don't know what the types actually are, and the better answer is to fucking put types on the factorial, because types make a fantastic way to document what your intentions are. I wrote fact without types on purpose, but you could put types on fact if you were, you know, going to want to do something there or want to know what you intent.
So I had a question earlier I was trying to ask.
No, I want to go
runtime.
to my question first.
Go ahead. Alan.
Okay, no, wait, Alan, Derek did jump in first. I'm gonna let Derek go.
I jumped in a
Okay.
while ago, but everyone cut me off. All
So
right.
did I. You can, I'm in, I'm not giving it up. So you were saying before that the runtime decides like whether to specialize the V calls.
Yeah.
And I'm wondering what the mechanics of that are, like, because like how can you, what are you doing to say like, oh, it's worth it to do it here, it's not worth it to do it there, and then how do you tell the compiler that?
So there's two things to consider. One is how do you do it automatically, and one is how do you let the user force. The do it automatically happens in JavaScript, V8 happens in Hotspot, happens a lot of places. Why you do it? You profile and discover there's a hot path, there's a hot type. The mechanics is after you have profile data, at some point when you're doing inlining decisions of some kind or another, you do an instance of check if it's the hot guy, and if it's the hot guy, you know the type forever after. And if it's not the hot guy, you go to your plan B, which is perhaps jump to the interpreter if you're Java, or jump to a version that's been generified, that is the generified version. So Hotspot does this already. In particular, in hot inner loops, if the profiles have been collected on a vcall and it turns out there's one hot guy, we'll do an instance of check and then inline the target method after the instance of passes. And if the instance of fails, if the hotness is sufficiently hot, we'll simply blow out to the interpreter. You'll basically get an assert that you're this type, and if you're not, you're going to run slow.
So in each peephole, are you looking at the raw data and saying, oh, this seems hot based on the data, or is something doing an analysis of the hot of the data, the runtime data, and then basically saying, here's the stuff that's hot, so if you come across it in a peephole, then do something?
So as part of the reading all the bytecodes, we gather the profile data and annotate the graph with it. So the profile data comes from reading the original bytecodes, and you get shit like what class it is and what other classes have showed up here, if any, and the relative frequency between things. We got too many windows open here. Let me throw the chat in. Oh, and Levo says he's trying to figure out how he got his answer. Okay. So, right. So at the peephole time, if I come up to a thing that says, make a vcall and I want to inline or not, or make a decision about a vcall, I make a decision, and I look at the profile data associated with that call site. And if the profile data has a particular pattern to it, yes, I run a peephole that says, throw an instance of down and make two targets. And one of the targets will be generic, the instance of failed, one of the targets will be specialized. Then a peephole again, specialized guy gets inline because he's tiny and he's static call. And a peephole the other side says, make a vcall, except the probability of getting here is so far 0. So I'll peephole you to a top it off and go to the interpreter. And then I have a loop that's got an if test that says fail out to the interpreter or carry on. And then I look to see if I can't move that out of the loop. And the usual way I do this is I peel the loop one iteration. And on the first iteration, I pass the vcheck. And all remaining iterations, the vcheck's constant time known, and it goes away, and I just have the body inline. So there's a way to do this sort of completely mechanically from the compiler, and Hotspot's been doing it for years. So the other one is, what can I tell the user as part of the typing system? And that's me deciding I'm going to push some amount of profile requests from the user or typing requests from the user through. One of them will be, I want to know I get the primitive version here. And I'll probably say, if you give me a type for your arguments that are all prims, you'll get a primitive version guaranteed. And I'll just change the peephole rules to say, if the user has done this particular pattern, force it. Don't pay attention to the profile data, just force it. And in particular, you might not have profile data if you're a cold start and you want to have a hard guarantee of getting the fast version on a cold start with no profile data. You can throw down types. And I'll just say, yeah, you just asked for specialization. So when I gave my fact is factorial of type int to int, and it says demand the int version, that's my theory on what that will look like from the user's point of view if he wants to demand a specialized version.
Yeah. Is that something that exists in any other languages? I don't remember ever seeing that, like demanding a version of something. Someone created a generic function somewhere, and I'm going to say, oh, I want a version that has these types. Like
Scala went for a time to attempt to call specializing, and you could say, I want the primitive int specialized version, had all the semantics of the capital I int, but you knew the implementation was going to be lowercase int, and he had strong typing throughout to guarantee he knew all the types. I couldn't get that to work on an early version of Scala at H2O. So like 10 years ago, it was not reliable. And
there is a problem with explosion of the code of the types we have to generate in order to be.
Yeah, so if the user asks for it, I'll explode it on the spot for that one. And if the user doesn't ask for it, the compiler also has heuristics to say, we're getting way too many copies of this shit. Let's stop now.
I've seen a way to make this statically. You generate the optimized version and the generic version and throw that behind an if switch. And if it's passed correctly, that can be made statically in without a JIT. But well,
right. I mean, it's a lot of runtime infrastructure work, but it's not hugely technically. It's not hugely subtly whatever from the theory side. I'm going to say it's not rocket science, but it is full of nitpicky details. So it takes a little while to get it done.
You don't have a chance to make the decision again. You generate the optimal version and the slow version. There is no in between. The JIT can specialize it later and not kind of the optimal and slowly get there of the optimal. That's what you win with the JIT.
Right. Yeah. Okay. In hotspot, you typically got inline is where you did the specialization, and you always arranged your inlining such that the hot loops were buried inside some other larger thing. So
how quickly the JIT gets to the optimal version of the code?
Yeah, he eventually gets there because he starts specializing things left and right.
So
but if you have a big enough body of code and you cross compilation boundaries enough times, in C2 at least right now, he won't specialize across compilation boundaries.
The cool trick is going there through the steps, small steps to the most optimal version of the code. And here, if you generate statically, you either assume all the things or you can assume nothing.
If you do it in the small step approach, you get monotonically improving performance. You don't have any potholes where you suddenly get big fast or big slow because you stepped across the line and suddenly went to the slow route. Like you get a smooth scaling slope of performance. And that's actually, users like that a lot better than the, oops, it's slow now. The mystery 10x slower because I'll do B calls for all my capital INs.
But
so you do want to do the route that
you have to if you have to bail out the interpreter, how do you keep some of the decisions about the code and where it did?
Yeah, this is called heroic optimizations in hotspot land. There's bits kept everywhere to track who did what at what call sites in case. And if you bail out from a compile, he goes to the profile data for that call site and he fiddles a bit. One of them is, I saw another class and here's the count on it. So at the bare interpreter level, every call site at the interpreter, so no cloning for inlining, has a set of types that has been seen and a count for the types. And it's a limited set. And once you get past 3 or 4, he keeps the top that he's got, but you can arrange that he doesn't count very well because he only keeps a limited count of types, doesn't keep all the possible types. And when you get to C1, call sites get cloned, and those cloned call sites get cloned specialized profile data. So when C2 gets called, he looks at the inlining tree given to him by C1 with private inlining data per inlined call site. So he gets a more specialized call path inline profile data.
Yeah, this
this scheme where C1 inlines and then have context-specific profile, it is specific to Azul C1. I think OpenJDK hotspot doesn't do that.
Yeah, what is that? OpenJDK didn't do a C2 inline first, a light C2 and then a heavy C2?
So what my main point is they don't have a context-sensitive profile.
Okay, fine. Yes. Azul C1, Azul has a context-sensitive profile data.
Yeah.
I did it. I know how to work it. It wasn't too hard in retrospect. Going forward, the hardest part was learning C1 at all. And then the actual.
Yeah, I think it adds some challenges to like ownership of the profile, like where this data should be stored, and it's kind of pain in the ass to this day.
We rewrote the profile data storage to be on the heap, and the Azul collector. Well, you should know all that shit. Well, but you're using. I don't know what you're using here now. We put I want to say we put all the profile data on the heap, and then it went with the code cache. And if you tossed a C1 inlining away, C1 inline copy away, you tossed his profile data away as well.
Yeah, but then there are some cases where we want to preserve the profile, and there's like it got complicated over the years, I would say.
That could be. I understand how these things creep up.
So it's due to an overhaul, but we haven't had a good motivation to do that yet.
All right, and then Alan, you were trying to say something.
Question.
Right. Okay. So first of all, I wanted to point out, so you have this like generic type signature with the operators and stuff, right?
Yeah,
That's longer than the original function.
that's correct.
So the question is, what does this type signature offer to the user over, say, a dynamic type system where they can just look at the function?
Oh, I wasn't going to hand the type signature out to the user. That's all compiler internals.
Right. Okay. But like, I mean, what is the point of inferring the type signature in the first place?
Oh, to verify that the matrix operator he's handing me hands me the correct signatures. It's a typing. It's your basic type system.
Right, but like if you just run it in a dynamics system, you'll already know that it will fail.
Okay. The goal here is that I'm statically typed. So if I run it in a dynamic system and matrix fails to have a less than or equals that takes an int on one side and a matrix on the other, I'll get a runtime type error. And I want to say, no, this is statically correct or statically incorrect.
All right.
So this is Python versus Java. I want static.
At the time of the call site, the type have to be either aligned, either make sense, or be rejected.
It's a classic static typing. I'm not dying at runtime with a type error.
Yeah, it's generally a win to pull stuff back.
My only point, I don't know it will actually help, but if you invert the problem, you have a data structure who you can query which that give me all the types that implement the minus type. Give me all the, but that actually may not be true because you resolve it at the call site. So only for the types you pass it in, you try to resolve them.
Yeah.
So okay.
Okay.
Mm-hmm. But still can make sense in a generic context, which you give me the set of the types that can fit here.
That's a different question. That's like go query the type system for all possible types that match this signature, which is maybe interesting, but it's not a normal. That's a reflective kind of question. It's not a normal coding kind of question.
Yeah,
That's the type of thing I would expect the Scala compiler to do.
Why?
Yeah, right. But then he turned around to try to make it part of the typing and add another phase to the compiler.
Yeah, because the Scala compiler tries to predict things globally.
Yeah.
And the only way it has to do that, look at the implicits, look at the like all those things. It's all about, if I know everything about everything, I may be able to answer a question right here. And it's
but the Scala type system doesn't resolve the signatures globally. It's a mix. It's a local type, colored local type system algorithm or something. It doesn't act like the Hindley-Milner in order when you wrote your program. Let's see what fits, and it resolves its types on a local scope. It doesn't query. Only the implicits are some kind of hybrid because they try to their its own type system, if you will, but only includes the types that are marked implicit.
Right, and I understand why they did the implicits. It's because they had to piggyback on top of Java while maintaining compatibility with Java. And the only way to do that was to add the implicits. So I don't like them, but I think it was a fine engineering decision given their constraints in Java land.
Although,
right,
yeah.
I have a question. Somebody's busy writing a runtime type tech.
Yeah, I just wanted to point out you're demanding the int version, quote unquote, is also like a dynamic thing. It's not at all, it doesn't need a static type inference at all either.
No, I'm sorry, if I do a cast in Java and it fails, I get a runtime cast check error.
That's Alan, that's on all at runtime. The static type system tries to exactly avoid this. It tries to fix this type before you run them, not while you run them. If you this type, then do this thing.
Well, I mean, that's like a separate issue, you know, is whether it's runtime or compile time.
Yeah. Cast.
I mean, I can detect unreachable code at compile time in a dynamic language. You know, there are plenty of tools for that. You know, and similarly,
you can detect some unreachable code
at compile time in a dynamic language.
At least my opinion, for the last 40 years, we're trying to move in the other direction. You're trying to move all the reasoning statically. All the things we can reason statically in the compile time of the program. That's a way we're moving in for 40 years.
And it's a trade-off, because each thing you try to move from a runtime decision to a compile time decision, you know, requires, you know, a certain amount of effort to have that knowledge available at compile time.
Yeah,
and,
you're lingering at the edges of what is known at compile time.
Well, but think about it. I mean, what are you ultimately considering? You're considering the runtime semantics of the program. So like whether or not it's compile time or runtime, it's still dictated by the runtime semantics.
Yes.
So when you're creating this more complicated static type system, you're really just trying to capture the dynamic semantics more effectively.
You're trying to constrain.
That's a better word. Constrained. Yeah.
As a longtime developer of very large programs, dynamic type systems fail out as you get beyond, you know, for Python at least 10,000, 20,000 lines of code, because you have so many runtime errors that would have been caught by a static system that you can't catch until you die in the dynamic way, and then you have to go back. It's much more effective use of programmer time to reach a correctly running program to go static as you get a larger and larger code base.
So I don't know if this is a popular or unpopular opinion, but I like the model of linting to say, yes, there should be a runtime, and I should be able to be like, look, I know I've only written a third of a program here, but just go, because I'm trying to run an experiment and see how it behaves and poke at it with the REPL. And before I do my release build, I want to know that I actually have a sound type system. But there are definitely times when I'm working where it's like, hey, Rust C, why are you bothering me that I actually have to make this thing consistent? I'm not going to get there. I know that I'm going to hit a failing assert because it's either going to fail with the yes assert or with the no assert when it gets to this point.
Yeah, so I usually just put a ... at the AA ... in Java. I do a throw unimplemented, and it just gets me past all these type checks.
Let me know if my microphone drops again. I was thinking about this same problem. I want to try to get a linter into my compiler, but the thing is, I'm going to have like a regular debug build, a more advanced debug build that will give you more warnings and some more static analysis, and then a release mode that basically does all of everything before that. Like, I'm hoping that would catch most of the problems.
More static analysis.
Yeah, so there's going to be just a debug that it's not going to bother you if you're comparing assign and unsigned, and not going to bother you for unused variables. And then a more stricter debug build, maybe a third more strict debug build that's more of like a linter. And then a release mode that says you have to have good code, because you know, stuff will crash if you don't if it's not enforced.
that's a kind of a big jump between the previous step and the last step. But yeah.
Well, I'm trying to sort out the
Yeah, I'm thinking about how strict I would want the release mode, because maybe it should be an option. Like a release mode should be a certain strictness, but I'm not 100% sure on the release mode.
you're like
It-
deciding to help with debugging, you'd want to have more static typing, and in release mode, you let people get loosey-goosey. But
No, in the debug mode, it's Lucy, and then more strict on release. Because I don't want to insert as much runtime.
Does you
protection if I
permit?
decide to go
What does you
rest.
permit to kind of go under the rug in order to advance to a more complete program, and then you have to fix your program because it's now it's all strict. But where is the trade-off here?
Well, I guess I really can't have release mode be too strict, but I would prefer that by default. But
if you get it past the debugger and you can debug and it runs in debugger, and now you want to make a release mode, and you turn on release mode, you get more errors you have to go correct.
yes, but they should be not very difficult. It would be more like
Yeah,
you have
Personally, it'd be
variables that
able-
are not used.
you know,
Either
you'll
delete them-
soon come up with people who want the stronger testing. So they don't, once they get to release, they have to change something. They break themselves because they changed something and they need to go verify they didn't break. So now they will go back to the debugger, but with the changed code and run again on the debugger and verify it all works. And of course, they made a mistake, so they had to go back and debug into the debug mode anyhow.
And,
So the
and
first thing
again,
you'll
the
run into is people who say, give me all the stricter tests at debug mode as a flag. If you're not doing it by default, that's fine, but give me a flag that says dash warn : all, whatever the GCC version is, and warns our errors and warn all. And that totally was a,
a
thing to get
warning would say, I will let you pass, but I warn you, this thing is not actually the best thing you can write or something.
Yeah, and I
most-
definitely see value in, I can do the build on my laptop and it gives me a bunch of warnings, and I can test my thing to see if I'm making progress in my development. And then when I say, okay, I would like to push this to Git, and Git says, sorry, I ran the build. You've got warnings. No, you don't get to go into the main branch until your warnings go away. But in development, I often want to be able to make progress by doing the build and testing things and learning things about my program before it's done.
Most realistically, I probably will not be able to make the release build more strict, but I would prefer that, because I notice every time I program on any project, if I don't have it more strict, a lot of bugs will get in and be there for a long time.
It reminds me vaguely of the deep sea horizon oil rig that exploded, ran all of their industrial controls on Windows XP in safe mode because they wouldn't boot the full boot, because they had changed their hardware in such a way that they couldn't actually do the full Windows boot. They could only boot in safe mode because it didn't call something for some piece of hardware that didn't exist, because it wasn't actually a PC, it was a deep sea oil rig.
Well, that's
like,
what
you do have to be somewhat careful with, like, oh, if you can run the thing in debug mode and it behaves differently, someone
Oh
in
my
production
God.
is going to run in
So-
debug mode.
I just
This is-
assumed that any deep sea oil rig would be a custom real-time OS controlled setup, not a Windows XP
It turned out
safe
a
mode.
Windows XP.
I don't think current oil rigs are running XP in
Crap.
safe mode.
That's where you want the
Yeah,
static
they've
analysis.
upgraded to 2007, Windows 2007.
That's why.
But the point is, they
static
needed a
analysis.
lot of pieces of Windows to go away because they were noisy and distracting and unpredictable and difficult to audit. So by running in like safe mode,
I get
it was a
it.
much smaller surface.
But why were you running Windows in the first place? Sorry, it's not my
Because
call.
Linux didn't have a safe mode. And if you're an oil rig, you need to be safe.
Safe,
Therefore, you
of
have
course.
to run Windows.
You can
because it's
get
the only.
safe mode variants of Linux all over the place. You go to any real-time OS company, they will have you a version of Linux that's been chopped down to nothing.
Oh, I don't mean chopped down. I mean safe mode, where you go to the GUI and you say
I'm sorry,
restart in
sorry.
safe mode. So
I
Linux doesn't have that.
imagine for enough money, I will paint the color of the prompt safe mode.
I'm sorry, did I forget the /s? I'm sorry.
What? And again,
It
that's
does
why you
remind
want.
me of when the Navy launched their, their Navy 2000 program or whatever, and so they had this big fleet exercise, and the flagship of the fleet was dead in the water because of a blue screen of death on Windows. And yeah.
That's probably where IBM got their like the IBM's first the first real-time garbage collector, really real-time garbage collector with theory behind it and everything, was done by David Bacon, and they called it the $1 billion GC. And it was because the US Navy's flagship destroyer wanted to have a hard real-time GC to go with their hard real-time Java. But I didn't know that there was a big public failure for blue screen of death from Microsoft, but IBM picked up, Federal Systems picked up that contract for $1 billion. Apparently got a really cool real-time GC out of it and $1 billion.
So how many of these developers, military developers, are develop their software in debug mode because they're fast to ship features for the ship?
Oh,
and then
there are plenty of people who only ship in debug builds because performance is good enough, and if they crash, they get a way better situation to figure out what the hell goes on.
I was piggybacking about the level loosely.
Yeah, right. No, I worked with companies where both directions were popular. Some companies just were going to ship debug mode. That was just what it was. They would not even strip symbols. When crashes happen, you had a debuggable in the field thing. You could sort yourself out a lot quicker.
That's acceptable if the performance is not the first concern, but the correctness is.
Right.
Yeah,
Right.
I wish we could do that sometimes.
Go ship and debug builds.
Well, just yeah. So sometimes when you have a crash in the fields.
Oh,
and,
yes.
Yeah.
Dump the JVM in debug mode. Yes.
Theodore, what was your question again?
I was kind of halfly joking about you wanting the debug build to be not as strict as possible. I was half joking that their ships develop their features in debug mode because they have to ship features for the ship.
That actually reminded me what you said a month ago. So I still have no idea how I would, because you guys, I know there's explanations of how to do it with the jets, but I'm not sure how to drop down into a debug build from after a release build. Like if you want to debug a release build, I have no idea how you do that.
Well,
yeah, without a jet, I don't know, because I don't need safe points like with a GC would require. I just like emit raw code, so I have no idea how to conceptualize how to insert safe mode when you don't need or safe points when you don't need a GC. And
okay, so
drop
GC
down.
This is separate out GC safe points from machine architected state safe points. So if you like to think this way, the universe is quantum. It goes all the way up through the JVM, but it could go up to higher levels as well. So atoms have quantum states. Your x86 processor running on its silicon, he does not throw exceptions at every instruction boundary. He will group instructions and issue them. And when he decides to throw an exception, it'll be at between groups. In certain kinds of hot loops, that means you will never get an exception thrown between two certain instructions because they're always grouped. And that shows the quantum nature of an x86. He doesn't throw it at every point. And that means within that group, he's free to ignore the x86 architected state because no one will ever see it. Same for a JVM safe point. At the safe point, you have a direct mapping from the hardware to Java bytecodes. Some call stack with some Java registers to some Java stack state. It's complete mapping. In between safe points, you don't. And this has nothing to do with garbage collection. This is just how do you represent a debuggable point where I have a semantics that's visible to the end user at the Java level, at the Java bytecode level, at the x86 instruction levels, all at the same time. So, you know, those three stacks all wind up at the same point. Okay.
What would happen if I try to call a function? Wouldn't I need to save points before every function call?
So no, but you're right. You're very close, but you're forgetting how the optimizer goes to town here. If I inline a function, the body went away. If there's no reason to stop and let you debug there, you'll never be able to break at that function call. But
There
wait,
is
you
a-
say, I want to break at a function call while I'm running my hot debugged code in a JVM. And this happens all the time. JVM always jits. You can always set a breakpoint. Okay, he deops all the methods that have inline copies of this function, or he sets them up to flip out to the interpreter. And when you go to whatever version of whatever method that you've set your breakpoint at, somewhere up the call stack of the JITted code, he's already set breakpoints. It says you can't call this function because it calls this guy as an inline way, and let me save points inside the inline guy. And then from there, he jumps off the interpreter who promptly recompiles without inlining the hot guy that you want to debug at, and then you get to the guy you want to get at in the interpreter.
Okay,
So this is
reminds-
all.
So would it be acceptable if you turn on a breakpoint at the enter a function, but that function gets inlined, you drop to the point where the supposedly instructions are being released. Your body of the function is somewhere here.
No, well, that's what optimized debuggers in C have often done. If you go to some amount of C codes, I know GCC does this, but other guys do it too, and you say, I want -03 and debug mode. He will kind of sort of guess where the inlining happened and will kind of sort of give you a point where you can kind of look around. But because the inlining may have been of a getter or a setter, and it's a single load instruction that common up with other loads, it's unrelated to anything that's nearby where you're at. That can happen.
I think it's
But
just the
that,
symbols and where what functions each instructions belong to. I was just wondering about
you have a fallacy in your thinking. Once you get done with inlining and common subexpression, any given instruction does not belong to a function.
The concept of the function is erased.
The function is erased. That's right. There is no concept of a function anymore.
And that's as a consequence, you couldn't guess the function arguments if you want to look at them.
Yeah, none of that.
Well,
function
to be
arguments have been
precise,
eliminated.
one comment to be precise, in dwarf information, you can emit the original provenance source location for the inline constructs. So
Yes,
even if you inline a getter and it had a single load instruction, you can annotate that this load instruction comes from this function that was inlined.
But
Yeah,
that's
source file.
extra
Not all compilers
information
do
you
that,
have to
but you
annotate.
can.
Yeah, but you can keep going and say, these 17 gets have all been turned into one load. So the one load says, I'm one of these 17 gets. Also, the user wrote the direct field access that also commented up to this one guy. Some also these direct field accesses that happen here. Then later, somebody smart guy comes along and says, this field's always null. No one ever writes to it. So I'll just put a 0 in, and that all disappeared as well. So these things can go sort of get arbitrarily far removed from what the original code was.
But doesn't like the theory that I've been operating on, and I haven't really kind of finished this, so I don't know if it'll work, is that as things get commoned up, I annotate them with everything that they've ever been.
Yeah.
And so then it's not that this load is one of these 17 gets, this load is all of these 17 gets.
Yes.
And then if it gets turned into a 0, then this 0 is all of those 17 gets and whatever else it also is.
And all the other zeros in the universe.
Exactly.
Yeah.
So
And that should work in theory.
yeah, so I'm not sure how I'm hoping that I'll be able to sort of say, well, I'm around here while I'm debugging the program. So therefore this 0 is probably one of these 17 gets.
If you have small enough programs, that's a great thing. And I have totally taken -03-G or debug code and made my best stab at figuring out what the hell is going on. The difference here is that a JVM gives you exactly that, but he does it by stopping the running program and then changing the code to call something that was less optimized and continuously less optimized that gets down to the function you're at in the interpreter. And you get the exact thing. And
but there's an overhead to the save points, right?
There is. It's not it's not huge, but there's a definite overhead, and it's a carefully, safe points are carefully ranged to not be huge. So it's not for free, they're not huge. It took some doing.
Well, but there are two kinds of overhead. One is dynamic execution overhead, which is tiny. And then there is the overhead of they capture the values that otherwise may not be needed. So they might prevent some optimizations from happening.
Yes. And the values stay live longer than might have garbage collected and stuff. Things happen. You get a pile of debug info too. But the dynamic runtime costs are typically pretty low. But this comes about because we don't throw safe points in everywhere. We start by having many safe points, one at every call, one at every back edge, because you have to have one in every loop, including recursive loops. So calls get one in case it's recursion and back edges. So you get a lot of safe points. Then you inline a bunch and you unroll the loops, and you get a whole lot of safe points mixed in with other code. And then the safe point people rules say, I only need one on any straight line path or any loop boundary. So I guarantee you one on the entry or the exit. However, I do that with the dominating cut, or I just force one. And then I look at the loops and I chunk them all out until there's only one in the loop. And if the loop's too small and the safe point looks like it's going to have big overhead, then I unroll the loop and now I have only one in the unrolled loop. If that's still too big, then I do unroll a jam.
Yeah.
Does anyone know if you can optimize only one basic block in LLVM? Because I'm not sure if it can.
What do you mean optimize only one basic block?
Because I was just wondering if I want to continue using LLVM as my optimizer, could I optimize one block and then have a safe point next to it? Or am I just stuck and have to write the optimizer myself?
So there's a cool hack you do with safe points that should slide by every optimizer. You treat them as if they are a function call that reads all the user's readable debuggable state. And if you want to allow the debugger to write, then they also write all the debuggable state. So from LLVM's point of view, he's got a call instruction that reads all things and writes all things that runs off to some separate compilation unit he can't touch and don't know what it does. So he preserves all those things.
Actually, LLVM upstream has the infrastructure for safe points for both GC safe point and the optimization safe point.
Okay, that's gonna be better actually than what I said.
Yeah. Okay. So it might be doable, but I'm not doing that anytime soon. I just want to plan it out so I have an idea.
Yeah. So one of the things that I've been doing in my compile, well, while I've been developing, is I've got this JVM option called debug non-safe points turned on. And that's just so that the profiler that I'm using can get apparently more detailed information. They recommend using this. I thought this would slow the whole thing down because maybe it was preventing optimizations or something, but didn't really have much performance impact. Kind of surprised by that.
Unless you've disabled like removing extra save points, they'll go away, and then what's left behind is not too expensive. But the other piece of that is, if you're not using a random stack sampler, if you're using a safe point profiler, those can lie to you very badly. You want a random stack sample profiler.
Okay. Yeah.
And they might be correct. And the bigger, more messy your program is, the more likely they are correct. You got hot looking Fortran loops, which you in particular may have. You want a random stack sampler.
Yeah.
I made that mistake with Python.
Yeah.
I had a program that I was like, it should be spending all its time doing these expensive matrix multiplies. Why does the profiler say it's spending no time in the C code? And it turned out the profiler didn't take stack samples in the C code.
Right. Yeah. Yeah.
Live and learn.
Yeah.
So I think this flag that is like non-safe points debug or something, it is for sampling profilers, and it is about how Hotspot figures out the information about a particular PC, which frames it belongs to. And I don't know how it is implemented. So they have the mapping based on safe points, where they just, I think, find the nearest safe point PC and then recover the frames from it. But I don't know how this other flag works, so I don't know the impact on performance.
In the Azul profiler, I tried very hard to arrange, or no, I made it work, that I knew exactly what compilation unit any PC belonged to. There were no holes at the call boundaries between a call and a return and a BP push or whatever. Those got all closed.
But
So-
when you have inline frames, so you can easily identify physical like frame and method, but you can be in several like inline frames in this PC, and profilers would love to see this information as well. So you either use the your safe points and recover the logical frames from there. We use Dwarf and we use the debug info produced by LLVM to do this mapping.
Yeah.
And as I said, I don't know what Hotspot does with this flag enabled.
So in the land of, optimized compiler goodness, the inline frame concept has no meaning because of everything got wiped out by the inlining. So you can't reliably give somebody, there's no semantically correct point to tell which the inlines are. So you can guess.
But it's I think it's the case with any kind of debug information.
Yeah.
As
In
soon
an optimized setting, any debugging, yes.
Yeah, it's kind of best effort. This is likely this stack, but no guarantee given.
Okay, yeah, as long as you're claiming best effort, then that's all good. And I want to say when I did the Azul like low overhead runtime stack sampling profile, I grabbed the PCs on the stack, but if you wanted to reverse that, and I did, to something at the bytecode level, I think I did exactly what you said. I went to the nearest safe point and gave you that stack sample as a best effort guess.
Are you using a Dwarf yourself? And if so, how did you learn it?
I'm talking to Arthur.
Yeah, so what we do is we get basically an object file from LLVM, and then we deconstruct it and put it into internal VM structures. And there is a place where we use the Dwarf produced by LLVM, and I think we use LLVM APIs to read it from the object file, and then we recreate our VM internal structure. So inside of a VM, this is not Dwarf; it's a more compact representation with a lot of details stripped away.
Okay, next topic.
I'd say 30 seconds silence, time to move on.
Somebody has a topic?
Well, did y'all do syntax highlighting already?
We didn't talk about it. I know Levo was having grief with it.
Yeah, I just wanted to take a break from the switch statement, so I tried it out. And one of the problems I ran into was, so in my language, you have the function and then the return type afterwards. So the issue is in the text me grammar, what I wanted to do was use a bunch of patterns to like highlight the type, but I'm not sure how to say this, but essentially it has to know where it ends before it can. How do I even explain this? Okay, so there's 2 points where there's an inner body in the function declaration. One of the
But you know what? I killed the screen share, but you might throw some code down, and then I'll just start screen share back up again.
I probably can explain it, but there's essentially 3 points actually that I would have to go recursively inside. The first one is the function parameters. The next one is the type, and then the last is the curly brace for the body. And the issue I was having is the last one with the curly brace. If you put it on a new line, it just thinks that the function is being declared, and there's no way to express. There's a new line allowed to recursively do a different rule, and it does not play well with the recursion, even though it has recursion all over the place in the grammar. It's not very well implemented, in my opinion. It's just, you can't say this happens after, which is biting me in the butt right now.
I thought you had a sample of your color coding efforts in Discord.
I had a photo, but I guess I can throw something up in the docs. I'll do that in just a minute.
Okay, I was about to, I found the photo. I can drag it into the docs here.
But you have your parser, right? Doesn't this make the syntax highlighting at least moderately easier if you have your parser for your compiler?
My voice or my sound was getting really choppy. Give me a sec.
What country are you talking from again? Canada?
I think it's just something with my Wi-Fi this morning because
Okay.
usually I hear everyone just fine. If you can repeat the question, I can probably answer it.
Why syntax highlighting give you trouble? Because you have your parser for your real language. Why just not use the parser step in order to figure out what to highlight?
This is for the VS Code. It's not like I can generate it just fine using my compiler, but I guess I would have to use the language server protocol to do better syntax highlighting. Yeah. I just opened up the docs. I'm just gonna type out my example.
Ooh. Oh no, there it is. Wow, Google ate my code. Google code blocks ate my code. Fine, I'm gonna go down and get Levos. Is this the like the BNF rules you're having to deal with? Oh, or a new line. Yeah, okay.
This is like the rules for what is considered.
Yeah, this is how you describe the, yeah, okay, fine. Yeah, how you describe the colorization.
It's not BNF, but it's close enough.
Yeah, a long time ago, a galaxy far, far away, I did an early R parser. And R has this, you can end expressions with either new lines or if you started a curly brace, it has to have the close, but if you don't have a closed curly and you're not in a curly, if it's semantically valid to end a statement at the end of a line, you didn't need a semicolon or anything. It just, you hit enter and that ended the line and that was it. And that led to kind of a bitch of a parser issue. Yeah, I tried to colorize my code for AA above and the code blocks was weird. I can't insert code in their little preview. And it wasn't dumping and being polite here. Someone's colorizing now. Are you hand colorizing? Who's colorizing? Is that Theodore? Is that you colorizing?
No. I believe it's Aaron, maybe.
Did you colorize the AA code, Aaron?
Yeah. He
Yes.
pasted.
Okay. How did you manually do it?
He pasted in the
I
VS
am
Code.
taking the string and I am moving it from docs to VS Code, and then I am copying from VS Code back to docs.
Fine.
Because VS Code copies as HTML and Google Docs can accept HTML and converts it back into its format.
Okay. I think I could do that in Emacs too. Now that you've said that, that occurs to me. I know Emacs carry coloring around.
But I did think it's kind of shocking that VS Code, which doesn't think in HTML, and Docs, which doesn't think in HTML, can talk to each other by copying and pasting HTML from each other.
Well, they're doing it now. They're doing like real rich text format.
VS Code does think in HTML. It's
Okay.
Electron.
Okay, fine. And here's some other code that's been colorized.
When I try to mess with lectures and parsers for you, I maybe try to, I don't promise anything, to push something on GitHub that would colorize our code.
So you have an issue here, Levo, like describing your colorization rules because you allow new lines to end different kinds of expressions, different kinds of syntactic constructs.
Specifically, it's like I guess some people can just like kind of have a hacked rule where the type or where after the last parenthesis, you're allowed to say new line. But since the recursive rules too depends on having a new line to end, it's not letting me have like the curly brace on a new line because it would just end the rule early instead of like process the next one. I tried using a forward look ahead, and that worked in some places, but it didn't work here.
This is the name of the function. You need the open parens, so you know that you're entering the arguments of the function.
Yeah,
so
the first recursive rules is just for the commas, the signs, and all that.
So that's problem. You will have to wait for the closing semicolon. You know you're passing the arguments to a function. So at the next step, you're trying to jump. You're jumping into some resolution.
The type is the return type.
Yeah, the
right?
type.
Yeah.
The return type, which could also ends either on the closing braces or a new line.
Show an example of code with it using a new line. Like, what's it look like? Like write factorial where you just did a new line instead of curlies there. I'm curious just to see how it reads.
It's actually like the declaration. I'm just gonna.
Right. Oh, and you put the brace on the next line. Why did that? Because you still have a brace.
I don't.
Why
think
wouldn't it
the
just
new
carry
line
on
would,
through the new line to the open curly on the next line down?
No, how many new lines you are? You're just jumping to the open curlies. So what would make semantically difference if you just ignore the new line and just wait for the open curlies?
Yeah, ignore the new line. Wait for the open curly.
Pardon, I was just typing in. I didn't hear.
Why don't you why don't you ignore the new line and just wait for the open curly?
There's some places. Yeah, I should probably do that. I have an extern C block where you declare the C functions and there's no bodies. So I have that. I have it like that because of that. But maybe I should just
can you write an example, short example to illustrate what you mean?
Right. Extern C makes sense to do something different. Or you could put force a closed curly, open closed curlies on extern C that's just empty.
But that's a different concept altogether.
Right, but he's getting confused, not confused, whatever, conflated things here.
So, okay.
So here's a function that you want to highlight as a function. Here's a pile of arguments you want to highlight as arguments. And now there's no body. There's the return and there's no body.
Extern C is semantically different construct in your language. You have to
so
pass,
you could say on extern C, the color highlighter chooses different.
That would be extern C construct, and inside it will have a tree, and that wouldn't be a problem. So the question,
colorizing rules.
Yeah, that's you have a problem because this interferes, this block interferes with the coloring of the function.
Yeah.
No, the thing is, this style, I don't have a body. So so when I wrote out my my highlighting rules, I just wrote it how it is in the parser. And I don't demand that you have to have open curly brace, because I thought it would also be a good idea that if someone forgot the body, I can give it an error saying you forgot the body instead of like something more strange.
So if you want to reuse this in the external functions and in the block of the functions, you have to abstract just this, or a function declaration without a body. And you have a class for this, and then in the function would take this structure you already name it with the body of the function. That way you can reuse this structure for the highlighting if you're trying to.
Wait, have you seen the highlighting? Let me post my last good version, and then you guys could see what I'm talking about.
Yeah, of course.
Here. About to say, next one is you hack your extern C to require like a semicolon at the end or some other syntactic break. So the color
Or-
highlighter works. Okay, yeah.
Or
Aaron,
just-
did you want to do syntax highlighting? Because I didn't bring up syntax highlighting because I'm not that interested in talking about it.
Mhm,
Yeah, don't worry about it.
mhm.
It's
Yeah,
fine, but
And
yeah, I think your compromises will be made here,
of course,
one way or another.
Aaron is our syntax highlighter for the.
The
This
manual,
is-
no, yeah, but I'm looking for manual. He's doing some other ones too that,
He
that
knows.
look good, you know.
Mm.
There's some colorization that helps there.
Mhm.
I like
okay, so
the-
this
Yeah, I've been
file's kind of
surprised how well the
big.
Java rules do on AA.
Mm.
Yeah, right. That's why I tried to cut and paste the Java with the code blocks. It didn't go. I like the colorization there. Yeah. Fine.
I'm gonna change this to plain text so it doesn't look like that.
Oh, it pasted fine, but fine.
Yeah,
We'll say
because
the one
yellow
piece of
is kinda hard
syntax
to
that
read.
bugs me with the AA is that the colon is both the ternary and types. It's like it's typing everywhere but the ternary, but
I
that's
go
such a
back-
familiar
right.
syntax that doing anything else is.
Right. I go back and forth and it's not syntactically ambiguous. I can always tell it apart in one character. But right, I'm with you on that. It's like,
The challenge is simple, which is, we've got Unicode, so we've got 12 zillion characters, but keyboards haven't gotten any bigger. So, I mean, the rule is we have to make bigger keyboards. So-
No, I don't need a bigger keyboard for this. That's not good. This is your, I gotta scroll and see for the video viewers. This is the current colorizing. Yeah, it's pretty ugly. Now buried in here somewhere is a way to tell apart extern C's functions from regular functions.
No, I don't make a difference between them, and that's one of the issues because it would be more simpler if I did. But
Well, I guess my suggestion was break out extern C as a separate match rule, and then it colorizes differently than the regular functions do, but I don't know. I'm not
Yeah,
writing a colorizer, so I don't know.
like I don't know if this is just a wasted effort and just something I just did for a day to take a break from Switch, or if I should actually try to rewrite this and get syntax highlighting. But the C rules are okay. It's not great, but it's just like okay. But the thing
Yeah.
is, if I have my own language, the debuggers stop working. So I would have to tell people to add in an extra line to the JSON file in the debuggers that they're using to include my language. So it's like, do I want to do that? It's like, maybe I should just not bother with my highlighting. Like, I think it's fine just to use the C rules, but I don't know what people think.
I think
Like, what
these
they
are all
prefer.
these are all things that you incrementally creep up on. Having any highlighting at all beats none. And then custom highlighting, because it's better than C highlighting, can wait until you get more excited people and you realize it's an issue.
I'm going to try to share my screen in just a moment just to show you the syntax highlighting.
Yes.
But I still think there's more interesting information that can be exposed that way. The first time I had an editor that would sort of gray out code that it knew was dead code.
Yeah.
Like, it's really powerful. If all of a sudden everything turns gray and you're like, why is everything in this file dead all of a sudden? What typo did I just make?
Yes.
Yeah.
Yeah.
That's a powerful
IntelliJ
feature.
will step forward in the debugger and keep flipping out code paths he can tell won't be reached on this pass to the debugger. And it's kind of nice.
Yeah. You know, in the land where you've got something that's like Ruby, where A.B could be a really cheap field to reference, or it could be database network traffic.
Yeah. Right.
It would be really nice if my dots were different colors based on whether they were field dereferences or whether they were database traffic.
Boy,
And
dots
like,
are hard to read with your eye for the color.
I think you should use font
fast.
size, so the dot gets bigger and bigger.
Yeah.
you just
Yeah,
get a
should-
dot that's the size of a letter, be like, hey,
It
just so you
bounces.
know, you just did
I can't see anything on
arbitrary
my screen. This
computation.
dot is so big.
It's not a size or color. It bounces if it's more complicated.
Oh, there you go. That'll help a
And
whole
if it's
lot.
really complicated, if it involves networks or databases, it has to go in a sine wave.
Anyone remember bouncing banner ads? Click me,
Yeah.
click me, click me. Jeez, they're like, you couldn't look at the website for flashing neon, ding, ding, ding. It's like, stop. Epileptic seizure time.
I remember reading websites like this.
Yeah. Yeah.
Yeah.
I switched to.
But I do think you could do that. Certainly in AA, where you're looking at stuff going, is this megamorphic or not? You could totally bold things that are virtual calls and
Oh,
what's the opposite of bold? Narrow things that
Right.
are known
Yeah,
to be
you know,
inlined.
fast.
I
versus-
guarantee you this will inline. I'm going to make
Yes.
it look kind of smaller. This thing's
That's-
actually a virtual call. I'm going to make it a little bolder.
That in theory, I'll have available as part of type, which means a language processor could highlight that way. Yeah.
Right. That's a
Yeah,
cool
just-
thing for highlighting
Yeah,
to
I
tell
didn't think
you.
about that. What the
Just
hell?
avoid to make the syntax highlighted into a fruit salad, please.
Can you guys see my screen?
No, because you
No.
have to go screen share or I have to stop. Let me
No,
stop.
Zoom
I theory
apparently
it's got it
now
public. Oh, and there's yours.
Allows
Fine.
multiple simultaneous screen shares.
Oh, okay, cool.
'Cause I've never seen that before.
So this is the default VS Code. Like, do you guys prefer dark?
Oh, I'm certain that everyone hates each other's preferences. So you should do once in light, once in dark.
I prefer sepia.
You could set it to evil to try and bug everyone.
I do light, and then like I said, yeah, other people like dark or whatever. So pick a dark and throw that as well.
Yeah, I'm just gonna stick with this because everyone probably used this and someone used to
Oh,
it.
not everyone. I used this for 30 years because that was what monitors did. Okay, 20 years what monitors did. And when I could get a light version instead of a dark, I just changed, never went back. Green
It's
screen.
all about that
missing
friendly
IBM
orange
360.
glow.
Green screen.
So anyway, you can see that the comments and like whatever, this is like not too bad. Mute isn't highlighted. If I do
Why is it mute? Your highlight, oh, because you're using C highlighting or something, because the mute's a
Yes.
keyword for you. Right, and on is probably not highlighting because it's not a keyword for C. And neither
Yeah,
is
so
empty.
this is not highlighted either. So
Yeah.
I do have this highlighted in my rules, but is this like good enough? Because like
Oh,
I said, if I offer a language, or I mean offer a highlighting, it has to have a specific language. And if you set the language to Bolin, GDB or the debuggers won't debug for it unless you change the package configuration. Like it's just like a one line that you add
I
into a
see.
JSON file.
You know what?
But I don't know if I want to hassle people to do that. Maybe C is just fine.
I would start with this by default and then say, and here you can get new coloring and new highlighting, and you have to hack the debugger, and then here's the steps to go do it, to get your configuration set up. I would make the barrier to entry as low as possible. And then
Okay. Yeah.
small steps to improve their life if they like what they're doing. Yeah.
So I'm thinking maybe I should just not bother at all. If you go to the Bolin Lang homepage, you can see at the bottom this highlighting, and it looks fine in my opinion. But
oh, it beats
yeah,
it beats nothing by a lot. So then I'd live with it.
yeah. So I think just for ease of use, I should just, because I probably would want to rewrite it in a language server protocol later on. So maybe I should just skip the step and not try to work on the highlighting anymore. Like I got the idea of like how it works.
Yeah.
But like it's just trying to improve it might be just a waste of effort.
Yeah, maybe. I'd let it ride and go get switches. And did you ever sort out your memory state, your memory rules?
What do you mean by that?
We had some discussion about whether or not when things could get deleted or not, or how you decided what the lifetime management was. And then you were mixing reference by reference versus by value. And
yeah, I understood what I need to do, but some of the specifics I would have to just to try out, just to see if I like it or not.
yeah,
Because
okay.
one of the things I introduced was stacking on global variables, and that's not going to make sense to anyone. And also append only, but for arrays. But I'm not 100% sure how to implement that. So it will work on not like if someone implements their own array, I'm not sure how to get that keyword to work with it. But I have like a plan to do all of it. It's just like 100,000 lines of code or something. So I don't want to touch that anytime soon because there's no way I'm going to complete it. At least not in a reasonable amount of time. Like I could probably do it if I'm full time, just working on it and don't have to worry about implementing other language features and making sure I don't break anything. But
that was my interest in Bolin was what were you going to do about memory stuff, and I'm hoping I'll see something out of it at some point.
Well, I could probably give you like a private tutorial just because you probably understand everything I'm saying. And
the issue of an implementation, even if it's a sort of a trivial one, is that it forces you to be correct. And the issue with having a discussion is that you get to play loosey-goosey with like writing pseudocode. You get to skip a lot of corners that turn out maybe in practice to be important.
That's one reason why I hate trying to explain this, because you can't see it.
All right, fine. Fine.
See, that's my problem with Rust. I look at the way Rust does the borrow checker and tries to keep track of who owns things and what can be freed.
Right.
I try not to talk about that language. Go ahead.
In 3 places simultaneously. I first look at it and go, this is way better than the stuff we used to have to do with C and C++. And then I hit my second response, which is like, but this is also clearly wrong because you spend a lot of time fighting it and like, whatever the right answer for it is not this. And then someone's like, great, so what should we do? And I'm like,
okay,
I got nothing.
Right. So what I heard you say was,
I know this is wrong. I know there is a better.
Right. C and C++ sucked, and we spent a lot of time debugging those bugs. And then I kind of got better at it, but it was still bitch. And then you're saying Rust makes it formal, and it's a bitch to get it all through the compiler and to make it right. You still can't do some cool shit that you used to do. But it's correct if you get past the compiler, and that still sucks because you spend all your effort making it right through the compiler instead of writing the debugger. And then surely there's a better way that everyone
Rust has a clearly bigger problems than the borrow checker right now.
Isn't there new
life issues?
Rust, the stainless or something? I don't remember what it's called.
All right, I'm good. Yeah. What was that? Stainless? Sorry, I missed.
I don't know. I mean, it seems like a good name for a successor to Rust, but what are they? Wasn't there a fork of the language now?
Yeah, the crab programming language. That's what I alluding to, because people are beginning to quit left and right. And
okay, so in 2014, like I'm not going to talk about Rust much because I really don't like talking about that language at all. This is probably going to be the only time I talk about it, like in public at least. In 2014, I just like looked at the language like really deeply. I'm like, I don't like any of this. And I had some of the automatic memory, like the plans to do it, like how it's going to work, or the designs rather, before there was even a public announcement of Rust. So when it publicly announced it, I'm like, oh, that's a little weird. Why do they tie the construction and memory allocation at the same points? Like that made no sense to me. So in 2014, I took a really hard look because they were saying that they were almost done, or people thought it was almost done. And I disliked everything about the language. Like it was just really messy. And the borrow checker was, in my opinion, worse than what I designed like years ago, but I didn't have an implementation. So what can I say? Right. And then for 9 years, I'm just hearing about the Rust this and Rust that. I'm like, I figured out Rust is like not very well implemented 9 years ago. Why do people keep on talking about this language?
The big leap was to make the memory management a static concern, a static analysis concern. That was the huge step. The thing
is, I never had that problem, like even 9 years ago. So to me, it was just solving a problem that was only for beginners.
To me, that is a key. That is a key word for
By the way,
a lot.
There was a very interesting post by Gradon
Yeah.
on Rust recently. The Rust I wanted had no future, and among other things, he mentioned that, for example, original plan was not to have explicit lifetimes, and instead
Yes,
have
that was
this
one of my
inferred.
complaints.
That's
Yeah.
actually, I found there's a lot of interesting points also about the traits versus module in the OCaml style. There were objections that the ML style modules were a little bit too explicit, but traits have their own implementation complexity, and maybe that wasn't the optimal choice. Of course, he generally makes the argument that if he were the BDFL, then the language would have no future. He's a pretty humble person, but I wonder. I think there are some good ideas in there.
That's
I just want to
reality.
say,
You make some good decisions and some bad decisions with the language, and you have to live with them. If you can change them, change them. If you can't, then
I misspoke earlier. I said that I thought that memory management was a problem only for beginners. I meant back then that's what I thought, but I didn't realize because all my coworkers, or at most of my jobs, we only use C#. So I didn't realize that experienced developers still struggle with memory. So I thought it was just like a problem for beginners. I'm like, what's the gain here? This is just all cons and no pros for me. So I just never liked that language after I took that first
at
debug.
least to me, in a huge code base, that kind of bugs are inevitable to creep in.
Yeah, well, sanitizers help, but back then I just had all the warnings turned up, and those are lifesavers. Like some of those warnings.
Well, Rust is the bro checker is such kind of thing. Don't let you compile, but
I tried it and I still found a lot of ways to break Rust. Like the single threaded deadlock. That's the stupidest thing I've ever experienced. Why would you deadlock any single threaded applications?
It's not
That's
perfect
the
for
C
sure.
API. And then, Java said recursive locks, which have their own costs to them.
Yeah, and then just one last thing I just want to mention. I looked at if Zake can handle string switch statements. I don't think it can. Like looking at the documentation and trying it didn't seem like it could. I also looked at Rust, and it does do that. But when I looked at the release mode, it literally did a string compare back to back for like the dozens of strings that passed it. There's no hashing involved. And it's just like every time I look at the assembly for that language, I'm just glad I'm working on my own language.
I mean,
that I
figuring out
understand,
how many
C just
branches you
fine.
have to do before you'd be better off with a switch is non-trivial.
Yeah. Yep.
Well, there's no hash. They didn't do any kind of hashing, so it's just literally dozens and dozens of memory compares.
If your most your switches are small and you have no profile data, it's just not a bad answer. Switches are typically not the hottest thing. They can be, but they're typically not.
Wouldn't you just or are we talking about switches versus if statements, or switches using a hash versus not using a hash?
No, I'm talking about using an implementation of switches as a series of nested ifs. It's an easy, cheap way to get started, and until it shows up in your hot bottleneck.
This was a release build of Rust, though. That's why I was surprised that there's no hashing involved.
Again, as long as it's not anybody's bottleneck, no one cares.
And CPUs are good at things that are not always intuitive.
Yeah.
I've seen code that tried to do a tree of ifs, and you're like, oh, this is nice and logarithmic and beautiful. And then it turns out that the straight if ladder that's like, did I branch, did I branch, did I branch, did I branch, did I branch?
Pretty quick.
You have to get a lot of those in a row before the tree is actually cheaper.
The branch predictors are in megabytes a second, so
it did. Yeah. I mean, measure. This is all those things. Don't optimize now. Measure first, and then come back around.
There was a time when I thought I understood what CPUs were doing. I have been cured.
Wow,
that's a great line.
Yeah, I claimed I knew for a very long time, and then gradually they've crept out from under me. Mostly, I think I still know, but I'm willing to be a lot more approximate now.
I thought I was pretty good at optimizing, and then I went from 900,000 lines per second to 3 million. And I'm like, the 900,000 lines me was pretty good, but yeah, there's a lot of mistakes I made.
Yeah. Yes. And you have a very small, tight piece of code you're optimizing there, which is all fine. But if you're running a general purpose optimizer over everyone's random crappy code on the planet, you get a whole nother can of worms to deal with.
Well, I only care about going fast in debug builds because most of the time I'm doing a debug build.
Yeah.
So,
yeah.
I have a Java question.
Yeah.
How did you manage to build a test suite that you believed was at least vaguely representative of the Java code out in the world?
Incrementally.
Because, you know, when you're optimizing C2, you have to optimize it against some pile of code.
Right. Yeah. Incrementally. I started,
how did you build that?
JVM with benchmarks, JVM 98, right? Because that was the era. And then the test folks kept pulling up bigger wads of people and exciting market things, said, God, we have to have a JBoss, we have to have a WebSphere, we have to blah, blah, blah. And they would run test stuff. And then for the longest time, I beat on them to say, give me a reliable harness that I could press a button and look at the performance across all your things. And that really took more than a year to get, several years to get. So in the interim, we would take complaints from people, and then I would go get an app up and running and run C2 or run the JVM on an app under load and look at the generated code and where I could do better.
Wasn't this all bytecode, and can you just take existing apps that people released?
No, it was not all bytecode. I only looked at bytecode. You're correct there. But I was looking performance. So I'm generating machine code and then I'm running it. So I run a large app, call it WebSphere under load, and you get foo bars per second or whatever that app's favorite measurement is. You get some sort of throughput measure. And then you sit down and you run your profiler and you say, this is network and I'm not going to touch it. And that's GC. And then this is the generated code. And I'm spending a lot of time here and there.
CPS was consultants per second. That was the WebSphere measure.
Yes. Yes. Consultants per second.
Your harness was source code and
choice for
bytecode.
CPU bound things.
That sounds like you end up in a place that's kind of, you know, there's this eye of Sauron that keeps finding a performance problem and staring at it till it boils away, and then find another one and stare at it till it boils away, rather than feeling like you're systematically going after the latency.
So once we had that profile platform out there that we could get a geometric mean across a large collection, that was QA guys basically built it up, then we handed them the obvious tuning knobs that I didn't want to deal with, of how much inlining and how often, and had them fiddle the knobs. And that was it was a hand roll job at that time, but there was a reasonable way to go say, this is this and that is that. And then, periodically things would pop up as on the small scale, I had a performance problem and I could tear it down and say, usually by that point, it was like a deopt-a-lot bug where some failure would happen and you deopt, you fail to set the heroic flag. So you JIT the code. So running the interpreter, you JIT the code, you got back in the compiled code, a microsecond later, it threw the exception and went back to the interpreter. So it was always interpreting and deopting and JITting continuously, all three things all at the same time. And then you fixed your heroic bug and you finally got stabilized in some JITted code that was reasonable. In there somewhere showed up a couple of security holes where the JIT knew that this was illegal and should never have happened. And so he refused to compile it. And the interpreter and the verifier thought it was all fine. And they would demand I go JIT it. And I would fail to JIT it because I knew that it was security illegal, right? Shit like that was going on.
So they're just bouncing back and forth. JIT this, no. JIT this, no.
JIT this, exactly,
no.
Exactly. Yes, exactly. Right. There's a bunch of that kind of crap going around. So anyhow.
Well,
yeah, it was a creep up thing.
I would say we more or less follow the same approach, that when we bump into something that we don't optimize well, we extend our set of benchmarks that we tracked. Although I think we still scratch our heads. We don't know whether this set is representative or not. Like, we don't have a great answer to this question.
Yeah, right.
And sometimes it's quite often with changes that change some cost modeling. Sometimes you want to make a change which will regress something, and because it's like changing heuristics. And yeah, you want to have a benchmark set that is representative.
Yeah.
And if in your benchmark set, you have some kind of patterns that is overrepresented, well, you might just overtune for them. And yeah, great question. We don't have a good answer. Like we incrementally increase the set when we encounter problems.
Right. Once the QA guys at Sun got the set to where they could add things fairly easily, it incrementally grew, and I felt became more and more representative. But yeah,
Yeah.
begin
Because we're having
with
that problem with
overtuned
the
for
database we
98.
work on, which is we have some idea of what the customer loads look like. And the database performs okay on the kinds of loads that the customers are doing, because for the things where the database wasn't a good fit, people don't use it.
Yeah, right. Yes.
So it's like, who are all the customers we don't have because
Yes.
they poked at it for 3 weeks and realized, oh, it super sucks at their use case in
Yes.
ways that we could have fixed had we known.
Yeah.
It's hopeless.
Yeah, I don't know. You know, once Java hit that threshold where it was the thing, everyone piled in, and then instead of piling out, they bitched. And so you went and fixed it. I guess some folks piled back. Yeah, I'm using Fortran again because you still suck at weather simulation. Okay, I suck at weather simulation.
One of the things we experimented with is generating benchmarks by fuzzing. So we use fuzzing for correctness testing, and it's great. But we did an experiment with generating benchmarks and just comparing it with like with OpenJDK. And if we see something with a performance gap of, let's say, 2x, for example, even if it's an obscure pattern, well, 2x is too bad to to skip. So that's one of the things we try, other than just looking at the set of existing benchmarks.
So when you say generating benchmarks, what does that actually mean?
So we have a fuzzer that can generate random Java programs.
Yeah.
And, it's like it generates loops. It generates I think some API calls. So it has a like pretty decent grammar, and we just wrap it into JMH, and then we measure the score there. And if the score is significantly different from competition, well, it's a reason to go look and see why.
OpenJDK, you go page in. That's interesting. Okay, cool. That was not there, I think, when I was there at Azul.
Yeah, another thing in this
I
kind
certainly
of
like that for anything that's got 2 different runtimes, to just be like, hey, can I just programmatically brute force find things that one runtime is way better at than the other?
Yeah, and
yeah, I'm out of luck. I can't see that.
Yeah, go ahead, Arthur.
Another thing we are experimenting, we don't have great results yet, but I think it's an interesting direction, is we collect profiles from everything that we track, and we put them into a database, and we can write simple queries like this kind of method: in which benchmarks does it show up? And I think we can do some kind of data mining over the profiles that we have. At this point, with these simple queries, like, okay, I know I can optimize math min or math max. How often does it show up? Like, what is the total count of ticks this method gets? Oh, it gets 0.1%. Well, maybe I will go optimize something else. Or like, okay, it shows up in these benchmarks, and actually it contributes a lot, so I know what I will improve.
I just say max and min show up at loop bounds, where if you got them optimized correctly, somebody could figure out a loop bound and turn that into a range check eliminated.
But can you elaborate?
Well,
So
somebody
min-max was
says
just-
try equals 0 to math.max of a.length, b.length, or something like that. And then if there's an obfuscation of what math max is doing to the compiler, he doesn't understand what he got. But if he knows it's a length and b length, then he can do a little bit of pre-math himself, math max, and say, okay, both a and b have identical lengths or whatever, and there's no range check fail here. So exposing things that show up on loop bounds, which math max and min both do, to the optimizer can help the optimizer figure out how to range check eliminate. I was just looking at an indirection way, like a couple steps removed. Like math max itself is always a clock cycle somewhere. It's really cheap, and it's a loop bound, so it's a clock cycle for the entire loop iteration, for the entire loop execution. But semantically, having it grokked by the range check eliminator is important. So I don't know what that means for LLVM's version of things.
Yeah, it's a similar story to save points that we discussed. That dynamic execution cost is not that high, but then like abstracting information and preventing other optimizations, or like opening other optimizations if you can simplify it.
Yeah. That one in particular I was thinking, but I'm sure there's plenty of others that show up that I would be curious. Like I did a whole lot of work to make sine and cosine tangent run fast, because at that era, the supercomputer crowd was trying to replace Fortran with Java, and were bitching because they had performance issues because they were used to having the x86 sine op, which has bounds issues. It doesn't compute your last op correctly. You have to pile on a bunch of other shit. Java was doing last op correctly. The extra precision wasn't needed, but the extra speed was. So there's a lot of bitching, making sine go fast. And if you look now, I'd say how many folks use sine in all the Java programs on the planet, I would say wasted effort. I get way more people would rather have me spend 2 weeks doing a tail call elimination than making tangent go fast.
Yeah, that's
Fine,
one of
I'm done bitching.
As time goes, different things become important.
Yeah.
For example, SpecGVN 2008 is the least interesting benchmark of our set, because it's like old style Java. It does some math. It doesn't have much of interesting and relevant code anymore.
Yeah. All right. I'm drawing to my bewitching hour here. I'm gonna, does anyone else have any new topics or questions they want to bring up, or I'm gonna wrap up?
I was just going to comment that I was amazed by certain functions that don't get called that often, but still manage to be a disproportionate number of all the cycles in the world.
Like what?
Matrix multiply, fast Fourier transform, and linear interpolation.
Yeah, fine.
lerp, FFT, and matrix multiply is one.
Yes, fine.
They're not called that often, but the people who call them a lot, they care.
Yep. Yeah, H2O fell directly in that camp. Absolutely.
Another week, I might want some kind of a test hardness, but maybe I should think about that in 2 months.
So what I was doing this week is adding the sleep to sleep instructions to my code. So basically I need to sleep on a set of flags in the
Doesn't that slow things down?
But they don't care, they're sleeping.
Yeah, that's right. You feel more energized afterwards. So so the tricky thing is that I want sleep, depending on the flags, to not interfere with optimization of things that it's not related to. So I've been trying to figure out how to sort of make sure that it's a barrier to instructions moving across it if they're related, but not otherwise. It's been a little bit tricky. Most of what I care about on sleep, it turns out to be related to things that are tied to state chains. So if I'm doing a rotation, there's some state chain related to the rotator cuff setup. So then by tying into that, I can sort of prevent other rotate stuff from crossing over when scheduling, so mostly I've been able to do this with dependencies and then setting up anti-dependencies. But yeah, I've been hoping to try and do it without having to actually put any special code in the scheduler, but I'm not yet sure if that's possible. I don't know if you've ever had to do something like that. Maybe it's a kind of unusual type of instruction.
Yeah, if a sleep and a lock pass each other, that could be interesting.
Yeah, well, if I've had a couple of problems already with circles, like circular dependencies that I've had to fix, just been bugs, and so far it seems like I feel like I'm getting there, but I don't know.
Are there atomic instructions, like atomic loads and stores in whatever machine you're using?
Only atomic ops with the host, and nothing atomic. It's not multi-threaded within a single unit. So
okay,
they're all parallel.
Because atomic loads reminded me of what you just said, because you don't want certain ones to be, you want some order for some of the things. And that just whatever you just said, it just reminded me of that.
Yeah.
but sleep is that like a MM pause instruction for x86?
Yeah.
Which is that what we're looking at?
Maybe I don't know that. I don't know x86 assembly that well. So
It pauses, halt the processor and wait for an interrupt.
yeah. So I'm
No,
waiting.
it's
Do you mind
it
popping
goes
up a
into like a
layer?
low power kind of thing, and
Yeah.
it's more for spin locks.
Right.
So if you're doing a spin lock, it reduce clock cycle, I think.
Yeah. So the reason that I can need to sleep is because a neighbor I'm waiting for a message from a neighbor, or I may want to wait until some work is done on the PE array before continuing. Sometimes there's for some stuff there's hardware like lock.
So these could be
that-
wait on signal more than sleep for time.
Yeah. Sounds like a dependency.
It's not sleep for time. It's never sleep for time. It's just wait on a flag.
Yeah, wait on flag. Yeah. Sounds like a dependency.
Mm.
Yeah,
I think that's more advanced.
How does your
So-
scheduler work? Is it like a
It's
event loop or?
scheduler. What do you mean scheduler? Like the code scheduler, or a scheduler at a high level?
Well, my understanding was you had a whole bunch of cores that were doing jobs that were not necessarily in parallel.
Yeah. There isn't a global scheduler.
Or, okay.
Yeah, so they're running. They tend to have limited number of local dependencies, so they coordinate with each other. So
You're pushing that schedule down across the PEs.
yeah, exactly.
Yeah. Okay.
Yeah. So this sleep thing is kind of related to making sure things are scheduled, or don't start doing work before you receive the data you're supposed to work on, type of thing.
Yeah.
Anyway, I think I'm making progress on it. I was just curious if anyone had any thoughts on that. But that's about it.
I was doing the global code motion for C2 and I had put any dependencies in, there were bugs that caused cycles that then would fail to schedule and
Yeah.
silently corrupted things. So eventually I sorted with an assert to figure out that I had a cycle I wasn't supposed to, and then other bugs show up, but those all got beaten down eventually.
Yeah.
That sounds like an expensive assert.
Some of these points you just don't care. So you threw in the extra edges for any depths, you scheduled, and then at the end you walked through the block one more time. It's already linear. Walk through one more time. Everybody gets scheduled. Oh, somebody didn't get scheduled. Okay, now you throw in a cert. And the debugger, you're like, oh, this guy didn't get scheduled. Why? Well, that didn't get scheduled. He's waiting on this and this. Oh, there's the cycle. And you got a cycle in your hands. Like, how the fuck do I get a cycle from? And then you're off.
My scheduler blows up if it has a cycle, so there's no question.
Mine blew up after scheduling, but you could blow up before. Yeah, exactly.
So I didn't have to put in a check. It just naturally blew up.
Oh,
so.
it just naturally blows up per cycle. Excellent. Okay.
This might be more of a language thing than compiling, but when I was writing my switch statements, sometimes I wanted to like just write out my code in just like plain language, and then have it generate some C source that I could just copy paste into the appropriate location. Is there anything? Have any of you guys done anything like that for any language or compilers or anything? Because I thought that like, maybe it's just like you can't really do it because I had a couple of reasons why it might not be doable. And I should just write out everything by hand in all the source code by hand. But it felt like it's just easier if I could write some source.
I've certainly had things that spit out pseudocode, but I had no pretense that I was going to execute it. It wasn't C safe, cut and paste and go.
Yeah. It's easy enough to copy paste some things that's like passing the parameters in and calling a function, but it's just sometimes you get the type system wrong, and that's why I have to do it in the front end into the back end, and I don't know. It's just like a lot of code I had to write just for switch statements. The switch statements itself was actually not that hard. It's just the strings, because there's some conversion going on. That's like not that simple. So yeah.
I do fancy, complicated prints all the time.
Yeah.
Because they show up in the debugger, I stop and I two-string something, and the two strings actually a big ass piece of work, but it makes a pretty printed
chunk of basic block code or whatever that I can go read at, but wasn't trying to make it C executable, but it would be plausibly readable.
By C, I mean some source code that I could just copy paste into my compiler.
Okay, yeah, no.
So you're trying to write a preprocessor macro that sneaks your language into other C projects?
Yeah, I just wanted to something like that, but like I just wanted to write a switch statements of like the kind of thing it would generate, and then just copy paste, and then have it just generate some code for me, and then copy paste that in. But yeah, it seemed like it would just not be worthwhile most of the time, because I thought that maybe the input parameters I would have to be very explicit about, and it would just like cancel each other out. Like it would just not be worth the payoff, because this just be an alternative way of doing something instead of saving me time. So I thought maybe I don't know. It's just something to ask, because I thought there could be a payoff if someone knows how a good way to do it, but I couldn't think of a good way to generate code, or generate code that I could just copy paste into my compiler.
Can you ask LLVM to target C99? I don't know if that's a thing.
Yeah, I used to do that, Levo, with anytime I was working on the back end, I would kick out the code from an existing compiler, examine it and tune it, and then paste it into my, assembly emit codes, and then change the code, change the assembly to actually whatever it took to emit that assembly to parameterize it. I don't know if that's the same thing.
It might be. Was it easy to implement, and did it save you time?
Well, it certainly saved me time, and the main thing was, I didn't want to have to reinvent every single possible optimization that other smart people had already spent time on.
Yeah, I also got to think about is the switch statements the only time I would want to use something like this, because most of the language is done. Like it's not completely implemented, but the syntax part is like pretty much done.
I found.
Yeah, I mean, you don't want to
internal
over automate something you only do once, definitely. So, if it's a tool you're only going to use, you think you're only going to use once, then you make a very simple cost benefit analysis of it that says, okay, what is going to save me time doing it just once? And that's all you write, and you don't need anything more. Do the rest by hand.
Yeah.
I find that most of my fancy compiler prints I have used for many times afterwards. Yeah, if you only have it once and you're only going to use it once, there's a different trade-off. But if you think you're going to do something here more than once, again and again, it's not just switch next time around. It's default parameters on functions, or it's going to be whatever the next thing is.
I got one question that I want to ask next week, but I can just say it now if you guys want to think about it.
If it's got a quick answer.
Well, I want the answer next week. I was just wondering, what can I do for my language that people would like? What's good in a compiler or a language that people might want to use, even though it's incomplete? Because like right now, I just want to write iterators and switch statements with strings and a bunch of other things that are not necessarily something you have to use to get stuff done. But I want to write my code that uses like that's like that I won't have to rewrite later. So I just keep on thinking I have to do the syntax, but I want something to be usable, which is they're like against each other. So I don't know how to draw the line there. So that's the question I want to ask next week. But I don't know if you guys want to think about that or not, but yeah, that's what I'm thinking about.
Okay.
Right.
Oh,
That's all for me.
Matt with yes, is it worth the time? That was a famous I forgot about that, Matt. Thank you. XTC XKCD bleh. Time trade-off. Very good.
Yeah.
All right. I'm gonna call it here.
Yeah.
Until we meet again.
See you guys.
Bye.